Hello, my name is Jaume Pujantell. I'm a software engineer. I've been working for the past half year at Collabora, and my talk for this LibreOffice conference is about how LibreOffice handles opening PDF files. During this talk, we will see different approaches and situations, including the way PDF files are currently opened in Draw, an alternative way to open PDFs used by LibreOffice Kit using PDFium, and the specific use case of inserting them as images into other LibreOffice documents. Right now, when a user opens a PDF in LibreOffice, the document is loaded in Draw as a graphical document. The current approach tries to translate different types of elements that a PDF file might contain into their respective types of shapes. Shape being the building block of a graphical document in Draw. This translation gives us an editable representation of the opened PDF file. But since PDF is a format concerned primarily with layout, it has no structural concepts like paragraphs and such. So a block of text might be imported as a single text frame or as a collection of small text frames with arbitrary divisions in between. This is an inevitable consequence of this approach, since when loading the document, Draw cannot differentiate between a set of closed text that makes sense to an end user, like a form, or bigger text units subdivided into smaller fragments. If we look at the example on this slide, we see that the title of the section has been imported as a single text frame, as expected, but the paragraph that follows it has been divided into almost different 20 text frames, some of which contain only a couple of words, which is not what a user would expect. Other kind of PDF elements like lines, polygons, Bezier curves, images and such have their equivalent representation in shapes. But as in the text case, no information about the relationship between these elements is imported. If we look at this example, this chart is stored as in the PDF as a collection of lines, polygons, text, and a broken image. All these elements are properly imported to their respective shapes, so the chart is shown faithfully. But this subdivision into shape elements might not be what the user looking at this chart expected. For example, the 4 blue bars are represented using a single polygon shape. The same goes for the red and the grid ones. This is a fine representation if the only intent of it to be showed at the user, but it's a confusing way to represent an editable graphic, which exemplifies the main problem with this approach, and that is the user has the ability to edit all the parts of the document, but that editing can be highly confusing and frustrating. Some edits can work fine, but others, even very small ones, might require the user to redo whole sections of the documents just to make the small edit. As an example, in the first text shown, since the title was a single text frame, it is possible to edit it easily while keeping the document sane. But any change in the paragraph greater than changing a letter for another will produce ugly results, be it overlapping text if it's adding text, or a noticeable gap for removing or shortening the sentences. The only way to truly edit this paragraph is to erase all its component text frames and replace it with a single text frame as it should have been from the beginning. Another problem with loading PDF documents like this is that draw shapes do not always use all the information that their original PDF elements contain. Here we can see a couple of examples. On the left, there is a PDF that contains an embedded font which the shapes cannot use, so as in any other LibreOffice use case, the font is substituted for whatever LibreOffice considers to be the best approximation. And in the right, we have a highlight annotation where the highlight is imported as a yellow rectangle, which loses all information about its associated text. So changing the text will not change the annotation, and vice versa. The annotation is just a floating rectangle that can be moved independently of the text, which is not the case on the original document. An alternative way to load PDF files in LibreOffice is implemented using PDFfume. Now, PDFfume is an open source PDF rendering engine. It's maintained by Google, and it is the engine used by the Chromium browser to display PDF files natively. The characteristics of this engine that are useful to us for the handling of PDFs is the fact that it can generate a bitmap representation of a given PDF file, and that it also provides an API to consult the elements contained inside the PDF file, their values, the relationship about each other, and so on. So how is PDFfume used in LibreOffice? In Draw, it is marked as an experimental function. It is controlled with the environment variable allow import use PDFfume, and by default this option is disabled. To use it, it has been turned to true. On the other hand, in LibreOffice Kit, the option to using PDFfume is always enabled. So services that use LibreOffice Kit, like Collabora Online, will always import PDFs into Draw using PDFfume. Finally, when inserting a PDF as an image into another document, PDFfume will always be used, independent of the environment variable, or if it's LibreOffice Kit or not. So, how does it look to open a PDF in Draw with PDFfume? Each page is imported as a single bitmap image This removes all the ability of editing the contents of the PDF of the open PDF file, but also removes all the confusion around importing and translating the PDF elements into their shapes counterparts. Also, since this approach, since it uses the engine to directly render the PDF, there is less loss of information. For example, it correctly uses the fonts embedded or partially embedded in the PDF and their corresponding styles. In this image we have the example of the text seen before imported with PDFfume, where each Draw page has a single shape that is a bitmap image of a PDF, and text is shown as would be seen in any other PDF reader, since it uses the font contained in the PDF. Despite the compatibility, despite all that, the compatibility of PDFium with LibreOffice is still incomplete. For example, PDF annotations are only partially supported. Some work fine, like the highlights shown before, can be imported into Draw using PDFium and looks as one would expect, but others still require some better support or are only partially supported. Here we have a couple examples. On the left, a couple of annotations has been added to PDF using Okular. Floating annotation that is marked with this sticky note image, and a line annotation that has an arrowhead decoration. The floating annotation is imported into Draw as the standard LibreOffice document annotation, and so it uses the author initials as a mark instead of the image included in the PDF. And the line is imported as a line, losing the arrowhead decoration information. Finally, I'll talk about the use case of inserting PDFs as images into other LibreOffice documents. While opening a PDF file has advantages and disadvantages in each of the approaches we've seen, inserting a PDF as an image is the ideal use case for PDFium. Since the objective of the interaction is to create an image, PDFium offers exactly what we need. And in a situation like this, user won't expect the ability to edit the documents, since the workflow explicitly states that it is being used as an image. This means that with PDFium we obtained better quality and better fidelity, as we've seen, without having any of the drawbacks of not having editability. Another advantage of PDFium, specific to the use case of inserting images in PDFs in other documents, shows when exporting that document to PDF. When exporting the parent document to PDF, the simple approach could be to include the image as such into the exported document, which would be the only reasonable approach if we were using the imported as draw shapes. But since we have the original PDF and PDFium happy to manipulate the contents of the PDF, we can insert the elements of the original PDF into the new generated PDF as cross-object and cross-object reference. This not only lets us preserve the things that PDFium gave us, like proper fonts and styles, but also lets us preserve more utility for future uses of the document, since instead of storing an image, it will store the original PDF elements that you were used to generate the images, like vector graphics, or even a same image but with higher resolution than the one being used to show to the user. This has been my talk for this conference. I hope everything was clear, and thank you for listening.